Hello. So this video will be focused on 11.2 of Perms and Combs, or the combination lesson. A combination is a selection of objects disregarding order. If you remember from the last video, in permutations, order did matter. But with combinations, order does not matter, making it a little bit easier to grasp. So we've got the formula for combinations, where N is the amount of items and R is the ones that you select to focus on. So again, let's say you had 5 items and you choose to worry about 3 of them in terms of combinations. That would be 5C3. This is the formula for combinations. R has to be bigger than or equal to 0 because of the fraction. If n, because 0 factorial is equal to 1, R can't be any negative number that just doesn't exist in Perms and Combs. So you shouldn't be getting any negative numbers for your R value, or else your calculator will give you an error message. And then your N has to be bigger than your R, or else you'll get a decimal number, which is also not possible in the application of Perms and Combs. So hopefully this was quick and brief enough. Let's go over some examples. Okay, so let's start with this first example. From 6 females, in how many ways can you select a group of 4 and a group of at least 4? Let's start with the first one. So a group of 4 females. We have the formula from before, which we know is n, r, n minus r factorial. So just plug the values that you have into this formula. N is the total amount and r is the amount you're focusing on. So it would be 6 factorial divided by 4 factorial, 6 minus 4 factorial, which can also be shortened to 6 factorial, 4 factorial times 2 factorial. And if you just do the math for this, which I will do very quickly, you get 15. That's all you have to do for the first question. The second part is a bit more complicated. A group of at least 4. The key word in this sentence is at least. You can have 4 females, and you can also have up to 6, because it says at least. So it doesn't want anything below 4, but you can have something more than 4. So we have 3 different cases in this scenario. We have a case of a group of 4, a group of 5, and a group of 6, which is all of them. So we just plug those values into our same formula. So we've got 6 factorial, 4 factorial, 2 factorial. I'll just do the math of this section really quickly. If you don't understand, you can just ask me about it later. Then we've got 6 factorial, 5 factorial, 1 factorial, 6 factorial, 6 factorial. Well, you could also put 0 factorial, but we know 0 factorial is equal to 1, so we don't have to worry about it. This will equal 1. 6 factorial divided by 5 factorial will equal 6. And then 6 factorial, we know that this is already 15. And as we saw previously, when you have different cases, all you do is add it up. 15 plus 6 plus 1 is equal to 22. That's how you do this first example. All right, so on to this second example. The first part of this question asks you to select a group of 4 from 10 employees. Let's just use the same formula that we've been using this entire time. So we've got 10 factorial over 4 factorial, and then 10 minus 4 is 6 factorial, which will equal 210. The second part of the question is actually trying to trip you up a little bit, because that is a permutation question. It's asking you to assign 4 different jobs amongst 10 different employees. But in this context, the order matters because the order determines which employee gets which job. So for this one, we use our permutation formula, which is n factorial minus divided by n minus r factorial. So we already know our n is 10, and then 10 minus 4 is 6 factorial. And once you divide this, you will get 5,040. And that's all you do for this example. Okay, this is the last question that I'll be going over. So we have 10 different toppings, and you can do a 4-topping pizza. This is the, again, exact same as every single other question we've done so far. 10 factorial divided by 4 factorial, and then we've got our n minus r here. So 10 minus 4 is 6 factorial. And I think I've got that number down. Yeah. We've got 210 possible combinations. Now, part B asks you if this is a permutation or combination question. To determine this, you just have to figure out the context of the question, and this is also an important skill to have, especially when you do your quiz, because he's going to try to trick you. The important thing to differentiate between a combination scenario and a permutation scenario is that in permutation, order matters, and in combination, order does not. In the context of a pizza, it does not matter what order you place each topping in. So it is a combination question. If we go back to this one, order matters because the order that you assign it in, these little lines are all separate jobs. So every time you place an employee in, it matters because what employee you pick will be assigned to a different job. If they were all the same job, order would not matter, but because they are different, each employee, it'll matter which employee you choose for each position. And that's all you have to worry about for 11.2, which is COMPS.